Every skyscraper, every massive bridge, every high-speed train begins with a simple rock buried deep beneath the Earth's surface. But how does that ordinary rock become one of the strongest materials ever created? Today, we're following the incredible journey of steel, from raw iron ore to the giant beams that build the modern world. Our journey begins in one of the largest open-pit iron ore mines on Earth. Here, gigantic excavators and haul trucks work day and night, removing millions of tons of rock to reach one of the planet's most valuable resources. Each bucket carries dozens of tons of iron ore, loading trucks so massive they make ordinary vehicles look tiny. Before steel can shape cities, support skyscrapers, or connect continents with giant bridges, it must first be extracted from deep within the Earth. This is where the story of steel truly begins. But reaching the iron ore isn't as simple as digging into the ground. Engineers first drill dozens of deep holes into the solid rock with precision, preparing the site for a carefully controlled blast. Within seconds, millions of tons of rock break apart, exposing the valuable iron ore hidden beneath the surface. As the dust slowly settles, giant hydraulic excavators move in, loading the freshly blasted ore into enormous haul trucks. Every load transported from this mine brings the world one step closer to producing the steel that shapes modern civilization. The journey doesn't end at the mine. The freshly extracted iron ore is transported to a massive crushing facility, where powerful industrial crushers break the giant rocks into much smaller pieces. From there, an endless network of conveyor belts carries the crushed ore through the next stage of processing. Every hour, thousands of tons of material move through this system with remarkable precision, ensuring a constant flow toward the steel plant. This is where raw rock begins its transformation into something far more valuable. Before iron ore can be turned into steel, it must be carefully refined. The crushed ore is washed to remove unwanted materials, then passed through powerful magnetic separators that extract the iron-rich particles from the waste rock. The purified concentrate is then mixed with water and binding materials before being rolled into small iron ore pellets. These pellets may look simple, but they are specially designed to withstand the extreme temperatures inside a blast furnace. Finally, millions of tons of pellets are loaded onto freight trains, beginning the next stage of their journey to one of the world's largest steel plants. After traveling hundreds of miles by rail, the iron ore pellets finally arrive at the steel plant. Here, they are unloaded and transported through a vast network of conveyors before being carefully stored and prepared for the next stage. But iron ore alone is not enough. It is combined with coke and limestone before being fed into the blast furnace, a structure as tall as a 30-story building and capable of operating continuously for years. Inside this giant furnace, temperatures can exceed 2,000 degrees Celsius, creating the conditions needed to begin one of the most extraordinary industrial transformations on Earth. Inside the blast furnace, an incredible transformation begins. As the iron ore slowly descends, a powerful blast of superheated air ignites the coke, generating temperatures hot enough to melt solid rock. At these extreme temperatures, oxygen is stripped away from the iron ore, leaving behind pure molten iron. The heavier molten iron sinks to the bottom of the furnace, while unwanted impurities rise to the surface, forming a separate layer known as slag. When the furnace is tapped, a glowing river of molten iron pours out, marking the end of one journey and the beginning of another. The raw iron is now ready to be transformed into steel. Although molten iron is incredibly strong, it is still too brittle for most modern applications. To transform it into steel, the molten iron is transferred to a basic oxygen furnace. There, a high-pressure jet of pure oxygen is blown into the molten metal. This process removes excess carbon and other unwanted elements while releasing an enormous amount of heat. At the same time, engineers carefully adjust the steel's chemical composition by adding specific alloying elements depending on its final purpose. Within minutes, what was once raw molten iron has been transformed into high-quality steel, ready to build everything from skyscrapers and bridges to ships, railways, and heavy machinery. Before production can continue, every batch of molten steel is carefully tested to ensure it meets strict quality standards. Once approved, the steel is transported in massive ladles to the continuous casting machine. Here, the glowing liquid steel flows into water-cooled copper molds, where it begins to solidify almost instantly. As it moves through the casting line, the outer shell hardens while the core remains extremely hot. Powerful cooling systems gradually transform the molten metal into solid steel slabs, each weighing several tons. These glowing slabs are now ready for the next stage of the journey, where they will be shaped into the steel products used all around the world. The solid steel slabs are still far from their final form. First, they are reheated to temperatures of over 1,200 degrees Celsius, making the steel flexible enough to be shaped without losing its strength. The glowing slabs then pass through a series of enormous rolling mills, where powerful steel rollers compress and stretch the metal with incredible precision. With every pass, the steel becomes longer, thinner, and closer to its final shape. Depending on its intended use, it can be formed into heavy structural beams, thick steel plates, rails for high-speed trains, or countless other products that power modern industry. What began as a simple rock is now taking the shape of the structures that define our world. After leaving the rolling mill, the steel is still extremely hot. The newly formed beams travel across long cooling beds, where their temperature is carefully reduced under controlled conditions to preserve their strength and structural integrity. Once cooled, giant industrial saws cut each beam to its exact required length with remarkable precision. But before any steel leaves the factory, it must pass a series of rigorous quality inspections. Advanced laser measurement systems and ultrasonic testing ensure that every beam meets strict engineering standards with no hidden defects or structural weaknesses. Only after passing these final inspections is the steel approved for shipment, ready to begin its real job in the world beyond the factory. The finished steel is loaded onto heavy transport trucks and delivered to construction sites across the country. There, massive cranes lift each beam high into the sky, where skilled workers carefully position and secure them to form the skeleton of tomorrow's skyscrapers. Piece by piece, floor by floor, these steel beams become the structures that shape our cities, connect our communities, and support millions of lives every single day. It's incredible to think that this journey began with nothing more than ordinary iron ore buried deep beneath the Earth's surface. From the depths of a mine, through fire, precision engineering, and advanced manufacturing, to the skylines of the world's greatest cities. This is how steel is made, the material that built the modern world.